So we're going to be talking about electron configurations today, and what electron configurations are. They represent the arrangement of electrons and where we can find them in the orbital shells. And within those orbital shells, there's suborbital shells, but where we can find these electrons in the electron cloud that Schrodinger and Heisenberg first proposed. So let's get started. There's different principles or rules when you're talking about electron configurations. And you don't need to remember the names of these rules, you just need to remember kind of the rules itself. The Aufbau principle is basically says that electrons fill the lowest energy level first, closest to the nucleus. So when we're looking for electrons, we're first going to look for those electrons closest to the nucleus, and as you get more and more electrons, you're going to get further away from the nucleus. The Pauli exclusion principle talks about in every orbit you're going to find 2 electrons in each orbit. This picture right here just shows you that sometimes we represent the orbits with lines, and the electrons we actually represent with arrows. So if you look at the Pauli exclusion principle, basically if you go to an orbital, you see that there's different locations for the electrons to be located, and you see the arrows that represent the actual electrons. Now, Hund's rule talks about the empty bus seat, the empty bus seat rule is how you talk about Hund's rule. And what the Hund's rule is talking about is that the electrons will generally occupy the different orbitals first before they start pairing up in their orbitals. So you see in step 2 in the p orbital, you see that you can find 2 electrons in each of the orbitals. Here are some rules when you're filling sublevels. You always want to fill the S sublevel before you fill the P, and then get up to the D and the F. In this class, we're never really going to go into the D and the F, so you just got to remember you want to fill the S sublevel before the P. The S sublevel is going to fill with 2 electrons, while the P sublevel is filling with 6, D fills with 10, and F actually fills with 14. So it'll make more sense as we start getting all the groundwork laid and we start doing practice problems. Let's look at this chart. Let's make a chart that has 3 columns and 3 sections. So pause me if I'm going too fast, but I'm going to start with the chart. Now these clouds are these main levels. So let's talk about the first cloud or first main level. We're talking closest to the nucleus. And in this first cloud or this first main level, this first main orbital, if you will, you're going to find 1 sublevel. And that sublevel is going to be called an S. And if you remember from the other slide, that S sublevel can hold a maximum of 2 electrons. So you're going to be able to find 2 electrons in that sublevel cloud or that sublevel orbital. You'll be able to find 2 electrons. Now if we get further away from the nucleus and we get to the second cloud or second main level, we're going to be able to find 2 sublevels, and they're called S and P. In the S sublevel, you remember from the other slide, you can find 2 electrons in that sublevel. In the P, if you remember from the other slide, you can find 6 electrons. Now, total in the whole second cloud, you're going to be able to find 8 total electrons. A maximum of 8 electrons can be found in the second level. If we get further away from the nucleus, maybe to the third cloud, the third main level, we're going to find 3 sublevels. The first sublevel is S, the second sublevel is P, and the third sublevel is D. In the S sublevel, remember, you can find a maximum of 2 electrons again. In the P, you can find a maximum of 6, and in the D, you can find actually a maximum of 10. If I add these all together, notice I can find a total of 18 electrons in the third level. What gets a little tricky as when you keep getting further away from the nucleus, the electron clouds start to overlap each other. And I'm going to give you a handout in class that'll show you how the clouds start to overlap. And I'll actually draw it right here. If I were to draw the 4th level right here on my smartboard, I would have 4 levels, S, P, D, and F. But what's weird is that the 4th level, its S sublevel, overlaps with the 3rd. So do you see how my purple line is coming in? And then the P goes around here. We have the D, and then we have the F. But I wanted to show you that. That's not really going to be on a quiz or test, but you're going to start getting overlap of clouds of where the electrons are located. So you're probably, still a little confused. I can draw another picture. So if we go back to this slide right here, this picture, this diagram right here with the numbers and the red arrows, that's going to show you the order that you would need to remember when you write your electron configuration. So keep that image somewhere readily accessible when you write your electron configurations. If you remember the Pauli exclusion rule that 2 electrons can occupy a space, and this next part will make total sense to you. You'd want to draw your nucleus in the bottom left corner of your paper. Then you have your first cloud, and we're going to represent our first cloud as level 1. In level 1, remember, we can find one sublevel, and that sublevel is called S. And what we're going to do in this diagram, check out my top left corner. An arrow is going to equal an electron. And we had originally stated in our previous slide that the S sublevel can hold 2 electrons. We're going to find those 2 electrons right here in the first level, the S sublevel. So this is called an orbital. This is what the Pauli exclusion principle said, that in each orbital you can find 2 electrons. So the orbital is this line that I'm representing right here. You can find 2 electrons in that first level, or that first cloud. Okay, so let's draw the second level, maybe something like this. So this would be the second level, the second cloud away from the nucleus, if you will. And we're going to, remember in our chart, we said that there's 2 sublevels, S and P. And since each line that I represent represents 2 electrons, if you remember from the previous slide, P can hold 6. So we would need 3 lines for all of our electrons. So let's draw our electrons in. If we have 2 more electrons, we're going to draw them in like this. Okay? And if we have even more than that, we're going to draw them in like this. Now remember Hund's rule from a different slide. It said that the electrons are going to occupy the different orbitals first. They don't like to be together. It's kind of like the empty bus rule, where if the bus is empty and you have any seat to choose from, that's great. You can sit wherever you want. But let's say you walk on the bus and there's one person sitting in a seat. What are the odds that you're going to sit next to that person? Pretty low. You're probably going to sit in a seat by yourself. So it's kind of like the electrons. These lines would represent the empty seats on a bus. And if an electron comes in and you see like this first electron in this orbital spot, it's going to jump to the next orbital spot, like a second bus seat, and sit by itself kind of thing. So we see all the electrons get in their each individual suborbital P. And then if you have even more electrons, because remember you can fill P with 6 total electrons, you see that they start to pair up after they go into their exclusive spots first. So that would be what the level 2 would look like. And remember, you can find a maximum of 8 electrons in this level. And in the first level, you can find a maximum of 2 electrons. And E minus is how I'm writing electrons. Let's draw that third level. And I'm going to draw this kind of weird because you start to get an overlap of levels, which is kind of funky. So we're going to draw level 3. And remember, we got to start off with S. And if you remember back to this diagram right here, if you don't know what order to start in, check out this diagram. I'll highlight, how I'm reading this. You start off next to the nucleus here, and then you're going to fill in your electrons in the 1s. After you fill the 1s with 2 electrons, you're going to be here. Fill the 2s with 2 electrons. Then go to the 2p. Then the 3s. Then you're here. Go to 3p, 4s, and it keeps going. And when you get really good at it, when you get to high school, you'll fill that whole thing out. It'll make more sense when we actually start writing the configuration or what looks like the code. But I just wanted you to reference this picture because it's going to come in handy later. Let's go back to this picture right here. Level 3, it's got 3 sublevels. So we have an S, and our S is going to look like this. Remember, we can find 2 electrons in the S suborbital. And then the P, which looks like this. 1, 2, 3 for the P's. Remember, they occupy the empty suborbitals first, and then they start to pair up. Okay, we got a total of 6. And then remember, we get into that D. And that D has a lot of energy. So I'm actually going to move this, try to move this green line up. I know you probably used a pen. If you used a pencil, maybe erase that green line that I have and kind of extend it a little bit. Just because for the D, I need to put 10 lines, and 2 electrons fit in each line. So let's see what we can do. Actually, not 10 lines. I want 5 lines. 2, 4, 6, 8, 10. So this is the 3D sublevel. Remember, the electrons will occupy each orbital separately before they start to pair up. Okay, and this is going to get a little tricky because when we get to level 4, so watch where I write level 4. Okay, so level 4 cloud is kind of overlapping the level 3 cloud. All right, and what you would have to draw, this is where it gets really tricky. The 4S is going to be a little bit lower right around here. So here's S, and you get a little bit of an overlap. Now this is this diagram with the arrows is a little higher level than I wanted you to have, but it's going to help you in high school, so I thought I would just give you the correct information. Let's get right into how to draw an electron configuration. So here's how you do it. We're going to start off with the easiest element, hydrogen. So first you want to write the symbol. And after you write the symbol, you need to ask yourself, how many electrons am I going to be drawing in this electron configuration? Well, in class we're going to be doing neutrally charged atoms. So hydrogen has 1 electron. So I'm just going to write it over on the side just to give me a little hint. As I'm starting to get used to this, I won't have to write that anymore. But we want to write the symbol with a colon. And then we want to write where that 1 electron is located. Remember, we start off by the nucleus in the first level, and we're going to find that electron in sublevel S. So this would be our main level, and this would be our sublevel. And we're going to find that electron, that 1 electron, in that S sublevel. So this is the number of electrons. So our final electron configuration is 1s1. If we were going to write helium's electron configuration, we would want to write it for 2 electrons. So that's just our little cheat thing. We're not going to write it all the time, but we're going to find those electrons in the first level, sublevel S, and we're going to find 2 electrons there. Let's continue on, and let's do lithium. Lithium, if you look on the periodic table, it's number 3, so it's going to have 3 electrons. Where am I going to find those 3 electrons? Well, I'm going to start off in the first level, S sublevel, and I'm going to find 2. Because remember, S sublevel can fill at 2. But I have more than 2, I have 3. So I'm going to put a comma, and then I'm going to find the 3rd electron in the second cloud, or the second main level. I'm going to find it in the S sublevel, and I'm going to find 1 of them. And to double check myself, I'm going to count these small numbers and make sure it adds up to how many electrons I actually wanted. Let's do one more. Let's jump to, we'll jump to fluorine. Let's jump to fluorine. Fluorine's going to have 9 electrons, and we're going to write it. The first 2 are going to be found in the first level. S for the sublevel, we're going to find 2 of them max. We have more than 2 electrons, we have 9, so we're going to go to the next level. Second main level, we got to start off in the S, and we're going to find 2 electrons. But we have more than 4 electrons we need to draw, so we're going to put a comma because we can't put any more in this S sublevel. We're going to stay in that second sublevel, but now we're going to go to the P. So if you look at your diagram that's all colorful, you can see where we're going. In the 2p, I need to put the remainder. I already drew 4 electrons out. Watch where I highlight. That's 4 electrons that I just drew out. I need 5 more. The p can hold 6, so I'm just going to write a 5. I'll highlight that. 5 plus 2 plus 2 gives me 9. And I'm done. So my final electron configuration for fluorine is 1s2, 2s2, 2p5. We'll do a lot more of these in class. Thanks for your attention.